Big Bang, God saying, let there be light. Are we all just an accident or here by design? Evolution or creation, which one is right? Do I really want the truth or just the theory that's mine? Who, what, where, when, how and why? I just want an explanation for the stars in the sky. Who, what, when, where, we won't yield. That's what God and Darwin on a level playing field. But it's how we draw the lines between that tear us apart. All want the truth, but we don't know why. Science is such a strange rallying cry. Who, what, where, when, how and why? I just want an explanation for the stars in the sky. Who, what, when, where, we won't yield. Let's put God and Darwin on a level playing field.
What are you doing here? What? Video series? What? Oh yeah, the video series. That would explain the camera. Well, thanks for joining me here today. You had no choice. Well, I'm glad you're here anyway. My name is Pfanstiel, and I'm a journalist by education, a teacher by profession. In fact, I've been teaching now for 6 to 7 years here in Texas. 6 to 7, not 67. And you caught me here cramming. I've been cramming for evolution and creation, the topic of this series, and they've fascinated me for years. The science, the politics, the debate. There's nothing so American as a good clash of ideas, a good competition. So when the producers asked me if I'd host this, I jumped at the opportunity. And that's just what this video series is, an opportunity to explore these ideas and these theories. So we'll be looking at the scientific methods, the nature of science, assumptions, interpretations, and the history of these theories. At the end of this video, we'll have a debate where we'll compare and contrast these theories. Now, how rude of me. Are you hungry? Let's go get a bite to eat.
Stop!
It was him.
What's going on here? Who started this? How did this happen? And where are all the teachers?
These questions have been plaguing mankind since the beginning of human history. What is going on here? Who started this? How did this happen? For thousands of years, mankind has turned to God or the gods to answer these seemingly unanswerable questions. Come here. Now, these answers and explanations are found in some of the world's oldest and most read books, the Torah, the Bible, the Quran, the Vedas. Now, all of these books credit mankind's existence to a supernatural God, creator. Now, over the last 200 years, this theory of creation has been upset by a new theory. Now, this theory takes into account certain evidences not known when these were written, such as the geological column, the fossil record, and the theory of natural selection, as proposed by Charles Darwin. Now, over the last 200 years, these theories have been fighting each other in boardrooms, in classrooms, in courtrooms, in conference rooms. Now, which one is right? Were we created in a moment by a creator or God? Or did we evolve over billions of years from molecule, to man? Now, both of these theories try to answer this question using science. Use evidence. What? Okay, that's not embarrassing at all. It is good, though. Did you know, speaking of American cheese isn't cheese. It's in the title, right? Well, actually, it's cheese food. Yeah. Which brings up another thing. My wife told me the other day that some experts are saying corn isn't a vegetable, that corn is a grain. Now, that's pretty upsetting. Corn is the only vegetable I eat. Why would my wife want to take away that part of the pyramid? I mean, without that, it's a flat... Anyway, which, come to think of it, these are both excellent examples of what we'll be discussing. We could argue all day about whether corn is a vegetable or a grain. But until we define our terms, we would just be talking crop circles around each other. And that would just be silly. Now, likewise, in the creation-evolution debate, we must first define our terms. What is science? And what are all these other terms that saturate the debate? Otherwise, one side could just say, well, you're not science, and the other side, you're not either, and they just get into a little hissy match. And then they don't have to consider the evidence that the other side presents. They can just ignore them. Not that either side would do that. Actually, yeah, they both do that. In this video series, we will be exploring the scientific theories of evolution and creation and the evidences used to support each of these theories. In each video, we will be exploring a different subject or topic of science and how scientists use the evidence to support their theories. We believe that both these theories should be tested, compared, explored, and discovered in the public high school science classroom. Now, in order to make a fair comparison of these theories, we must first level the playing field. Many argue education has become a monopoly of thought. Now, as a teacher, indoctrination is easy. I just tell you what to think, and you think it. True education is a lot more difficult, teaching you how to think for yourself. Now, monopolies are great. All the land, the power, the money, the hotels, the silver dog, which is my personal favorite. Life is glorious. Now, if you don't have a lot of money and you land on somebody's house with your silver dog and their hotels, and you lose the game, life isn't glorious anymore. Just call your brother a cheater, and life isn't fair, and not that I've ever done that. I'm a good sport, just don't ask my family. Now, if scientific history teaches us anything, it's that the monopoly of thought stunts exploration and discovery. Competition is good. It forces the stronger theories to survive and evolve while killing off the weaker, less compatible with life theories. Speaking of competition, which baseball team was the best baseball team in the 1920s and 30s? Best baseball player? Many baseball historians would say Babe Ruth and the New York Yankees. But we just don't know. Now, sure, they won 8 World Series championships in that period of time, more than any other team. But they may not have played against the best players. Many of the best players were not allowed to play in baseball because they were black. Now, this injustice would only be solved decades later when Jackie Robinson and other African Americans were finally able to compete regardless of their race. So we find ourselves today in science. One theory is the accepted, orthodox version of how things happened. The other is excluded, not because it lacks scientific evidence, but because it makes people feel uncomfortable and it just doesn't fit in. Besides, if Babe Ruth and the New York Yankees were the best team, they could easily have defeated Satchel Paige and the Kansas City Monarchs in a series played on a level playing field. Play ball! Oh, man. In part 1, this part, we will try to prove our argument by exploring science, the scientific method, scientific terms, compare the fields of philosophy, science, and religion, and review assumptions and bias, 2 elements of logic used in scientific reasoning. Now, in part 2, we will explore the theories of evolution and creation, the history of the debate, the scientific evidences that support each of them, and various transitional theories that connect them, and even have a debate of our own. So what is science exactly? Well, science, it comes from Latin and literally means knowledge, which makes it really easy to remember. Now, how do we get this knowledge? Well, scientists gather this knowledge by experimenting and observing the world around us. Now, this exploration takes scientists everywhere. from the microscopic level of atoms and cells to the everyday world around us of water and clouds and storms and lightning and tornadoes and hurricanes, the climate that we live on, and the very rock that we live on, and the rocks that we throw at other people while we live on this rock. Science also takes us to the heavens above us, to our atmosphere, the moon, the asteroids and the comets, and the universe beyond. Science also looks at the forces that shape this world, such as magnetism, sound, electricity, and chemistry. Now, as mentioned, each side tries to disqualify the other side by labeling it as religion, philosophy, something other than science. Now, is this fair? Now, imagine each of these areas, science, philosophy, and religion. In definition, they each approach truth from a different angle and a different direction, different means. So therefore, they must be mutually exclusive. But is that true? Well, the thing is, they're each seeking after truth. As they go towards truth in their own direction, science by what is testable and observable, religion by what is revealed by God, and philosophy through deep thought and introspection. As they move toward truth, instead of three separate circles, they end up as something of a messy Venn diagram. Now, when we see in this, there are areas of overlap. Science overlaps into areas of religion and philosophy, and vice versa. Now, with the claims of evolution and creation, evolution delves into religious areas, into a religious realm, whereas creation makes scientific claims. Now, neither theory or the variations in between, more about this in part 2, will ever make everyone happy. Depending on how you look at it, each side has a majority, and yet they don't have the majority. I love statistics. Just pick the one you like. Now, in America, the majority of Americans, according to a recent poll, believe that God played some role in the creation of the world around us. On the other hand, the majority of scientists believe in naturalistic evolution, which excludes a role for a creator or God. Now, which one's right? As a democracy, should we just go with the votes and only teach creation? Or should we just go with the majority of scientists and only teach evolution? Well, both are important. What we're going to do in this series is give you the evidence, give you the theories, let you weigh them, research them, try them, and then make up your own mind. Now, these two scales represent the idea of fairness in the American justice system. In many courtrooms, they're held by a Lady Liberty who is blindfolded. And this is to symbolize the idea that justice is blind. And that whichever side weighs more, has weightier evidence, wins, and justice is served. This is why this video series is called On a Level Playing Field, because we believe that on a level playing field, the truth will always win. I love the revelation that Neo has in the movie The Matrix, when he discovers that his whole world has been a computer-generated lie created to keep him from the truth of the world around him. Well, this video will do the same thing. We're going to take you on a journey. Now, this journey is going to open up science like never before. But it's also going to frustrate you because you're going to have to test and try things you know are true and things that you believe are wrong. In the end, I think the key question that each of us has to ask ourselves is, do you want to be right or do you want to know the truth? Now, as you process this video and subsequent videos in this video series, we hope to accomplish 4 things. First, we want to engage your critical thinking, comparing and contrasting. I mean, you're going to look at 2 very different theories. You're going to compare them and contrast them, hence comparing and contrasting. And your analytical skills. Analyze this stuff, test it. Now, you know what they've been telling you since 2nd grade to do all these things. Now you get a chance to do it in science class, not just when playing Halo 3. Second, as you take this journey, you will consume science like never before. It's almost like we're tricking you into learning science. Except I just told you we're tricking you. Third, no amount of testing will disprove good science. Now, bad science on the other hand, don't test me, just trust me. No, bad science doesn't want to be tested because then it'll be proven wrong. Good science, you can test it. Apple, law of gravity, I can test this 1 billion times. I'll get really old and my arm will fall off, but it will fall every single time. Unless Jason, our graphics guy, is bored. Okay, thank you, Jason. Finally, regardless of where you start and where you end, this journey will help you understand those that you disagree with. Now, racial integration needed to start in the public schools before society as a whole could become integrated. Thus it is with theoretical and ideological integration. As we learn more about each other, what we agree on, what we disagree on, we can agree to disagree. This world would be a better place. Isn't that what we all want? Makes me want to join hands with the people in here. Sing Kumbaya. Come on, guys. Come. Okay, leave me hanging. Fine, thanks. Now that we've covered our goals, let's establish a method by which we can achieve these goals. What would be a good method? Scientific method. Thank you, Dora. Now, the scientific method still works. It still works, even after all these years. I know you were taught it back in elementary school. Works to this day, kind of like good science should. Now, the scientific method, as we know, you observe, then you make a question, then you test your question, then you analyze the results, finally you draw your conclusions. To help us do that, we're going to return to the cafeteria and the scene of our crime. The principal wants to know who started it, why they started it, and how it got so out of hand. Now, this is no small task, so the principal calls in the school's SCI team. That's for the Science Crime Investigators. Yeah, I know, weird school, not very creative either. Anyway, the first step for the SCI team is to know what questions the principal wants answered.
I need to know who did this right now.
Next, they'll observe the crime scene looking for clues and evidence. As they collect data, they'll begin to form hypotheses for what, how, and why it happened. Now that they've collected data through observation and formed hypotheses, they can now conduct experiments to collect even more data. With these results, they can draw conclusions that either prove or disprove their original guesses. After numerous hypotheses are tested, it is then time to form a theory that combines and makes sense of all the data and conclusions made. Now, it would be easier to just line them up and let them rat each other out. Unfortunately, all the students who saw anything have gotten a lawyer. Typical. And the rest don't know that much, or in the nurse's office crying. So we have to do this the hard way, which is appropriate because when it comes to our own origins, we don't have anyone alive that we can interview. We can gather clues from the writings of others throughout history, but written records only go back about 4,000 years. Once the SCIs collect all the data from their observations and experiments, they can start analyzing it and drawing conclusions. These conclusions either support the original hypothesis or contradict it. Either way, something is learned and each experiment narrows down the search or turns it in a new direction. While evidence and data are usually collected and measured properly, the interpretation of the evidence is very subjective. The greatest difficulty humans have is in coming to an objective position in regards to the evidence. While evidence and data are usually correct if collected and measured properly, the interpretation of evidence is often very subjective. Now, subjectivity is when you see something from one point of view or angle. Objectivity, on the other hand, is when you see the whole object. Now, you have to do this by viewing it from multiple angles or points of view. Now, to assist us in becoming more objective, we need to review two elements of logic. Now, logic is what scientists use to help them reach proper conclusions. And these elements are assumptions and bias. One of the reasons being objective is so hard is because we each bring with us our own experiences, beliefs, and preconceived idea to any situation or experiment we take part in. This is collectively known as a bias. Now, you need to know about this potential of the tipping of the scales when you weigh the evidence so you can draw proper conclusions. Now, to prevent this, in my case, I have a bias. To prevent this from tipping the scales and making it an unlevel field, we have given this video and shown it to multiple experts and scientists. Their feedback and suggestions have been noted to help make this video as objective as possible. Now, the next concept of logic that we need to consider is that of an assumption. Now, we've been told to never assume because of what it makes out of you and me. But in real life, we make assumptions every day. sometimes these assumptions we make prove incorrect. Have you ever assumed that the boys in your house put the toilet seat down? It didn't pee all over it. Oh. Or that the other drivers on the road were as good of a driver as you were. I'm such a good driver. I'm gonna weave it out the road. It's all about me. Or that your journal was sacred and nobody would dare read it. Oh, okay. Oh, that's just wrong.
Philip, you said you wouldn't read it.
Oh, stop being such a baby. Oh my, you love... Testing, testing. Okay. I forgot Logan was our audio guy. What a baby. Now, in life we use assumptions all the time, but when we make the wrong assumptions, any conclusions we draw from those assumptions will be wrong as well. Ironically, in science, the biggest controversy between evolution and creation is in the realm of assumptions. To illustrate this, imagine a man who needs a haircut. Now, he's on a business trip and stops in a town with only 2 barbers. Since he needs a haircut, he decides to observe both barbers to help him choose the better barber. He visits the first shop and finds a neat, tidy, and pristine barber shop run by a handsome-looking barber with an expertly groomed hairdo. He then visits the second barber and finds the exact opposite. This barber shop is a complete mess. Hair is all over the floor, and the barber's haircut matches his shop. Which barber does a traveling businessman have cut his hair? In our story, the data we collect through observation is the same, but the interpretations will vary. Raise your hand if you go to the messy barber. Okay. Raise your hand if you go to the clean-cut barber. Okay, teachers, can you help me count the hands? I'm kind of having a hard time seeing through this camera, much less the time and the space separating us. Oh, Einstein, please help me. Oh, that's better. Now, in my class, when I've used this example, most of the students choose the clean-cut barber, and this decision makes sense. The assumption is that this man takes pride in his appearance and profession and is ergo a better barber. However, our businessman chose the messy-haired barber. Why would he do that? Well, he interpreted the data differently and made different but logical assumptions. First, the messy barber is obviously busier, which is why he hasn't had time to clean up his shop. Second, and more importantly, since there are only 2 barbers, they had to cut the other one's hair. So, the handsomely cut barber must have given the poorly cut barber his haircut, and vice versa. Or at least that is the conclusion he reached based on his assumptions. Were you right? Was the businessman right? Which is right? Fortunately, it doesn't matter. It was just an illustration. But the illustration does show us the role that an assumption makes in interpretation and the conclusions we draw from those interpretations. Now, when we make an interpretation and a conclusion, we want to organize these somehow. Now, science gives us a tool. It's called a theory. A scientific theory organizes and gives a framework for lots of different observed phenomena and experiments. It puts them all together. Now, in everyday usage, we say theory and we use it as some kind of hunch or guess. Well, scientific theory is much more serious and comprehensive. Like the picture that assists in putting the puzzle pieces into their proper position, a good theory makes sense of many different and smaller pieces and connects them. It also shows where the missing pieces are links and predicts future discoveries. Now, this ability to predict future discoveries is what sets a great theory apart. Now, the Russian chemist Dmitry Mendeleev, he came up with this periodic table after observing the property and structure of elements and atoms. And as he was coming up with this table and theory, he's like, hey, we're missing some pieces. There are some missing pieces. So when he made the table, he left blanks. And he said, hey, these are the elements we know. This is their structure. There are certain elements we don't know, but I know they exist. I just don't know what they are. Years later, those elements were discovered, thus validating his theory. In science, a theory may take years or decades to develop, and it may last for hundreds, if not thousands of years, but even this length does not necessarily mean that it's true. Only that it's the most widely accepted theory until a better theory comes along. This is what happened at the end of the Middle Ages. Copernicus suggested the heliocentric theory in opposition to the geocentric theory. Now, geocentrism was the idea that the Earth was the center of the solar system, if not the universe, and everything, the sun, the planets, the moon, the stars, everything revolved around the Earth. Copernicus suggested that the planets and the Earth and the stars all rotated around the sun. Heliocentrism. Now, when Galileo embraced this theory and shared it, it was not well received. People made fun of him. They knew the Earth was still and everything revolved around it. I mean, what kind of idiots were they? Galileo was completely off his rocker. I mean, all the facts supported it. The Earth stood still, the sun rose and set, the stars swept across the sky, and the Earth stood still. The wind winded, the oceans roared, the Earth stood still. Made perfect sense. Galileo was not well received. In fact, he was persecuted. He was sued. He was taken to court. They put him in prison. He eventually died under house arrest. Fortunately, we know better nowadays.
Thus ends part 1. So, what do you think? You've heard our argument for a level, balanced playing field on which to compare and contrast each ideas, examine their evidence, conclusions, assumptions. So, should you be given this opportunity to look at both theories, or should it be only one? And if there is only one, which one should it be? Oh, dang spiders. Oh, they freak me out. Now, personally, in my own life, the testing of my beliefs has been a good thing. Now, it's uncomfortable at first, but as I test my religious beliefs, my political beliefs, my economic beliefs, my beliefs about anime, some of them become much stronger. Robotech is the best. Others, I change a little bit, and some I completely throw away. Now, you know, this search for the truth it's kind of a disgusting habit, but I can't stop. Anyway, in part 2, we'll be taking both of these theories for a test drive and examining them more. Look forward to seeing you then.